Good morning and welcome to our latest CATIA design talk and the final one before the summer break. My name is Honorata Frings and today we will talk about perceived quality. We want to take a look on all the departments which are involved in the development of a new product and see why it is so helpful to use visualization to validate products and check its quality. With me, I have two guests today, Stefan Ritz, Portfolio Management Director at Dassault System, and Daniel Dresemann, Portfolio Senior Specialist, also from Dassault System, obviously. Welcome, gents.
Hello, Honorata.
Good
Great to
morning,
have.
Honorata.
Good morning. Let's start with the first question. What exactly is perceived quality?
So, Honorata, perceived quality is actually an important factor in the product development process. Imagine you have done a very valuable design and you want the customer actually to feel that there's a valuable design. So you need him to perceive the value of your design target. Another good example is actually when you use very valuable materials. Of course, you have a valuable material and a valuable selection and combination of materials. The customer has to perceive this, else you spend a lot of money, maybe for nothing. And a third very good example is when you have a very, very good manufacturing quality in your factory. Of course, the customer has to perceive this manufacturing quality, else you might lose a competitive advantage at the end.
Right. And can you give us a little more examples of aspects of perceived quality?
Yes, so perceived quality actually is about perception. So it's everything you can perceive. It's about our senses. So meaning what I can see, what I can hear, what I can smell, what I can touch at the end. And for our talk here, we are focusing a lot on visual perceived quality because it's a very good example on how it's impacting our design and development processes. So Daniel and I, we were searching for some examples here in the office and also outside at the parking lot to show you some of the important factors and aspects of visual perceived quality. And the first example we found outside in the parking lot on our own cars, and this is actually surfaces. So the surface quality are defining the perceived quality. So meaning it's really, or is defining the perceived quality. So that's one of the aspects here. And as you can see, in this little example, we have not just surfaces, we have also materials, which I found here directly in the office. So we have actually car paints in the office that we are using to apply on a surface. And the car paints themselves have a different behavior. So I have another good example for you. So they have a different behavior actually when they are applied on the surface, they change their behavior. And this is not just true for the outside, for example. So you have also here, for instance, leather, which is also a good example for the perceived quality in the interior. And I know that Daniel has also some examples with him.
That's correct, Stefan. For deco lines in the interiors, let's stay in the interior. We have here some metals, or very typical also, as is an example for wood here. And let me give you another very nice, interesting example here is this nice carbon material, which is now getting more and more interesting for interiors and exteriors in cars or other products.
That's cool. Thanks a lot.
Yes, and so for perceived quality, actually, these factors have to work together. So materials and surfaces, as you see in this example. So you have to apply actually the materials. And you see also the limits of the real world that we show here. It's actually, we just had small patches. We applied them manually, which was not perfect. We could not see them applied on the full product. And also collaboration was a little bit difficult because one of us had also to hold the material. So, but it's illustrating quite well that materials have to be applied on surfaces and that you want to check it. Another factor actually, and very important, is that you see nothing without this factor, which is light. So light has a practical aspect here. It is showing our design, it's lighting our design, it's lighting our whole material set. But it's not just a practical component. It also has a big impact on the perception of a material. So you see here with the car paint of the car, it has a big impact on the perception of the material. So these were just some examples on the visual components, on the design and visual components. Talking about manufacturing, in the middle of the design, we talk about another important factor. So meaning the gaps that you see in here are actually impacting a lot the perceived quality of the design. And we found also a new factor directly with our examples in the car, and these were the HMIs we found. So you see here the HMI is embedded in the examples we have seen before, with the surface, with the light, with the materials, and the HMI itself has a content, so might impact with its content the perceived quality. And it's also introducing new factors like interaction, as you can see here, which might be also important for the perceived quality of your product. So overall, we found already a lot of examples for the visual perceived quality just looking around and for the explanation here for this little talk. And this is already quite rich. And this is just touching the visual aspect of perceived quality.
Yeah, and that's why we are going into deep. So many aspects and factors influence perceived quality, as we have seen, obviously. And there are many departments and people involved in the development process. When do they usually check the perceived quality during this process? Can you give us some examples?
Yes, Honorata, I can give you an example on that one. And for that, we need to take a look at the typical product life cycle. So we are starting at the design and going up to the mass production. So as you can see here on screen is all the milestones, all the different departments are involved in this process. And historically, a physical prototype was needed to do a perceived quality check. So as you can see, the first 3 stages were not included in this process. That means there's a lack of studies, there's a lack of information for the later physical product and the physical reviews you can do.
Mm-hmm.
So let's introduce a digital tool for that, and let's do this digitally. And this brings you a very good information very early in the stage, and you can enrich then your first physical prototype and get a lot more information and accelerate the process. So coming back to your question, Honorata, is when do we want to do perceived quality? And we want to do it all along the process, because every department has a need to do such checks, such reviews, and it is very important that you can do it all along the process, virtually and also physically.
Right. Understood. So we need to solve this virtually in order to be more effective in our product development process, obviously. And how are these perceived quality checks enabled with software? What exactly are you using to perform these checks?
So the software solution has to, first of all, take in consideration all the aspects we were discussing before or were introducing to you before, as well as enabling or connecting the people working on these aspects. And that leads us directly to our solution, the 3D Experience Platform, which is a very good answer to this multidisciplinary problem, because the 3D Experience Platform actually should enable, with applications, designers to make a proper design. Then we have simulation. The application is also integrated. So people that want to simulate, for instance, manufacturing gaps should also find their right application there. Since we are on a platform with managed CAD data, they should be enabled on the single source of truth with collaboration tools to collaborate on this task. And perceived quality finally is about perception, as I said. So there is also a need for an experience based on the current data and based on the current step of the product development. And that's actually enabled by the 3 Experience platform. So let me guide you through some examples, because till now it was just, some very big targets for our little example here, but we have real examples with us to explain to you. So first of all, you can design surfaces. So a creative designer can start by sketching here an application that is enabling a creative designer to start really very early and build out of these sketches 3D. So very quickly he can build a 3D representation of a product. And this 3D representation later on can be reused then by departments that follow. So for instance, engineering or surface refinement. These departments take the data and refine it. So meaning they make a more refined representation, or they build engineering components embedded in this surfacing. And so they have the full capability of building a full product from a refinement or engineering capability. So till now, we were just talking about surfacing a lot or building 3D. But I was touching also, or was talking about also about experience. So we have built in on the 3Experience platform actually also the capability for this. With our Visual Experience Designer role and the embedded application CATIA Live Rendering, you can take these surfaces that we were just mentioning before and visualize them with proper materials, proper lights, for instance, a proper environment with high-end real-time rendering as well as global illumination rendering. So with the capabilities actually explained here and with the capabilities to generate an experience, we can enable, for instance, material research. We have shown already some examples in our live or in our real world search for the aspects of perceived quality. So in the software, what we can do here and what Daniel did is actually he took a real example, he scanned it physically correct with the capability of integrating physical correct EXF scans or X-rite scans represented in the EXF format, and he applied it on this material. So with this application, he can actually check how the material is looking now on the surface the designer have done before, and also he can check how different materials are working. So he can work with scans, but also procedural materials like substances to reach it. And he can make actually a very good here combination of materials to check how they are combined and how they are really interact for the perceived quality of multiple materials applied on the surface. So this is helping us now for decision making. So our example from before is now done virtually. So we have our leather examples actually that we tried, or leather patches that we tried on our seat. We apply them here on the 3D data. We have them on a touchscreen here with Visual Experience Designer. We can see them on the full interior actually applied, and we see them also on all of the surfaces, not just on a small part. So this enables us to have a very interactive session and prepares also the next discipline or the next discipline involved for perceived quality, and this is color and trim. Color and trim takes actually all of these components, including the 3D data managed on the 3Experience platform, and enables an interactive session to build trims or packages, material packages. So what you see in here is an interface that applies or that really exposes all of the different material choices I have, the capability of switching through them, applying different sets of materials to different parts, and build a trim out of it. And this very intuitively, very interactively, and again, based on the CAD data the designer has done, the engineers have done before. Now, this can be also checked in terms of lighting. So we said light is an important factor. What you see in here is this, that with Visual Experience Designer, you can actually check the impact of the light from the product itself on the materials, as well as the impact of the environment light on the product. You see here we switch to different environments, and you see it's impacting the perceived quality and also the appearance of the materials. And also HMIs, as seen here in this example, might emit light, which leads us directly to the next step, and this is the capability of working with HMI design. So what Daniel actually is doing here, he is prototyping a HMI design in an outside tool. So he has actually a standard tool. He's fully prototyping an interactive HMI. He can use it, test it in this tool, and now on the 3Experience platform, he's integrating it into the product design presenter and checking it in context of the surface, the light, the materials, and now integrating all the components of HMI. So he has a quite complete check of the perceived quality, including this HMI component also. And now we come to gap and flush.
Yes, and that's a good example for another form of collaboration, because as we mentioned before, gap and flush is something very special, and there are more departments who have to collaborate to get this done properly. And I think maybe you have another example to show us how it can work.
Yes, so gap and flush is very interesting because it's actually at the heart where design and manufacturing planning on simulation might meet. So you see here in the example, for instance, on the left side, we have a surface. The surface has a certain intention, and also the material applied to the surface might have a certain intention or target. And this is usually done by design. And with manufacturing or manufacturing planning, now the gap is impacting this surface and the design intent a lot. So depending on how manufacturing is really planning the gap and also the manufacturing processes, this impact might be bigger or smaller. And on the right side, we see also a very good example on multiple materials surrounding a gap. So this has also a big impact. I have a few examples with me on our working example for today, which are showing how materials or different materials are actually impacting the gaps. So you see the gaps appear a little bit more noticeable sometimes, less noticeable, and also appear differently. And actually going through all the different variations of materials, you can see also that we have a very, very big impact of the combination of the gap as well as the materials. So it's impacting the designer as well as the engineer. So to really help both disciplines or the disciplines involved here, we have actually made a portfolio dedicated for these checks. This is on the one side, integrating the visual experience designer, as I said before, for visualization on CAD data. On the right side, we have the product design presenter as our application for managing variation of materials and other components for color and trim sessions, for instance. And in the middle, we work with a partner solution from DCS, which is a 3DCS solution for tolerances and gap and flush planning. So with these solutions, actually, we can do the whole process, or we can accelerate and we enhance the whole process, which we can show now in the next slide. So here you see on the left side, a designer can use the tools integrated on the 3Experience platform to, first of all, specify what is the tolerance, what is the gap, what is the manufacturing position of a part that he finds acceptable for his design.
And on the other side, the engineer can import these results, these data, and tries to reach these acceptable variations inside the engineering tool and tries to predict these to predict if this is possible or not.
Okay, so let's take a look here on the example. So what you see in here is actually the 3DCS Variation Analyst, which is embedded on the 3Experience platform containing the managed CAD data. So I, as a designer, as I explained before, in this tool, I'm able actually to define the position of the part for gap and flush, the gaps actually for the gap definition, I find acceptable for my design. So I really go through all of this component. I can define the min and maximum I want to see to really express my design intent and also follow my design targets. But I am in a tool that is more tailored and made for manufacturing planning and engineering purposes. So there might be a point where I want to go to my world, which is now happening here with the product perception experience. So I can import what I have done before in the 3DCS tool and now have full access of my specification, so my spec studies. And I can switch on global elimination rendering, and now I see all my specification applied on my color and trim intention. So I can have actually all of the different gaps here really visualized with the materials I have defined before in global elimination in my tool, so I can really check between the color and trim intention, the design intent, and as well what I have defined as an acceptable tolerance for engineering following later on. Now I'm at the point where I can really hand over to engineering, actually.
Thanks. And that's what I wanted to say. That's the point where I take over as an engineer in this case. And what I want to show you here, first of all, in the 3DCS again, is that the engineer can build up his assembly process. So after that, he can run a simulation, a so-called Monte Carlo simulation, to predict the parts, how they will produce, because not a part can be produced to 100% perfection or assembled to 100% perfection. So he can see all the min and max iterations. And of course, again, he can bring them into the product perception experience to get a better experience, to get a better understanding of the parts, how they behave with realistic rendering and realistic reflections. And you can see that on the left part, I imported my results. And on the right side, you can see the same model within the spec studies. So I can, as an engineer, compare my results to the designer's input, what he thinks is acceptable. So I can directly compare those two results. And of course, what I can do as well is I can not only compare them, I can also switch on here again the Stellar Render Engine to see that really with the correct reflections and correct shadowing, which is really important when it comes to switching colors. So again, we can do this here in the perception experience because it is important to see where and which color has a different impact on the specification, on the gaps and the flushes. As you can see here on the black one, you can barely see the gap. And if the color gets brighter or you have a different color, you can see the effect more efficiently, definitely
Brightly.
more.
Obviously.
Sorry, Renata, you wanted to say something?
No, I'm just helping you out with the word. So it's brighter and it's more obvious. The gap is more obvious the brighter the color of the card.
That's what I wanted to say. Thanks. And then the next topic will be that Stefan and I met in front of of a touchscreen, and I hand over to Stefan to comment this.
Yes, so what you see in here is actually a final session that we wanted to show to you because it's really combining all of the capabilities. So we are in product perception experience here, very interactively having the product in front of us. Daniel can bring his results and I can bring my specification, and we can have a discussion, a vital discussion, and we can really see live the impacts like a customer would perceive the impacts of our different manufacturing simulations here. So I can explain also why I made the specification like I made it. I can also have a discussion with Daniel, for instance, on factors like reflections here and different material choices and the impact of his manufacturing simulation. We can turn the data set, as you can see here. We can really have an interactive discussion. And this is enabling a very, very intuitive and also very effective collaboration between design and manufacturing simulation, which is the target of our 3Experience platform. And I also have in the following video an example of a new feature that we have built in. And this is about not just about the gap and position of the part, we also can now show the deformation of a part, which is important because it has a very important impact on the reflections on different materials, as you can see here. So this is a new addition or the latest addition to this effective process that we can offer now. And it helps hopefully the people to get a full view of the different manufacturing simulations, also for the designers, for the engineers, and the manufacturing experts.
Very good. So we've seen many examples for the visualization today. Is it planned to have any other senses included into this perceived quality checks?
Yes, so actually it's already not planned, it's already possible. As I said, we were focusing a lot on the visual aspect of perceived quality. But as you can see here in this example shown on screen, together with our brands CATIA and Simulia, we can also work on other checks, like here, the airflow simulation. So it's a real simulation that has no visual sense, but it is really impacting the perceived quality a lot. So we can simulate this already integrated in the 3Experience platform, and it's just one example on a lot of other checks we can run for perceived quality here.
This is quite a complete and very, very interesting usage of the 3D Experience platform for visualization and for perceived quality checks, but also for design reviews and design decisions. Thanks a lot to you, Stefan and Daniel. Thanks for the presentation and the examples. And now I would like to open the Q&A session. And as we have received many questions already, I need to go back a little bit into the chat to show you the most interesting questions. I need to go up. Of course, we had, just before we start with the questions, we had the discussion here already that you cannot touch things. And of course, when you do things virtually, digitally, you cannot touch them. But you can have many more variants to check your designs, your engineering and everything. And for the touch, you can have like the examples, the parts like Daniel showed and Stefan showed you, when you have material examples that you can really touch. And just imagine your car, in this case, it was a car, goes into production and now the customer wants to buy one. He also wouldn't have all the materials to touch or to get into a car for all the variants that he can have to choose, that he can choose from to buy his car or her car. And therefore, it's just awesome to have all these digital possibilities to, to make all these variants visible. And now I would really like to start with the questions. So let us take this one first. Can we check gap at flush also with some tolerance? It cannot be always perfect. From VJ.
Yes, of course we can do this. 3DCS is offering and included, fully included in the 3D Experience platform. So it's a CA partner of ours, and we have a long relationship with them. So the whole tool from 3DCS is completely integrated in the 3D Experience platform. That's a good thing, because you don't need to convert anything. You can directly start with a physical product, put into a simulation container, and then you can start off and go right away with that, and put any tolerances on your gaps and flushes, of course. And then, yeah, you can, of course, check them in the perceived quality reviews within live rendering or product perception experience.
Thank you. I hope that makes it clear, VJ. Let's go to the next question. How is the data converted and imported from 3D CS software into 3D Experience software?
Yeah, as I just said, this is exactly what you don't need to do, because you don't need to convert any data. You have your physical product, you have your CAD data, and from there, as the 3DCS tool is fully integrated in the 3D Experience platform, you can directly start off your project and apply the measurements, apply the moves, as I showed, the assembly process, or of course, you can apply spec studies and everything like that directly on the CAD data, and you don't need to convert anything. You don't need to export anything. You just go from 3DCS into the product perception experience or live rendering and visualize it.
Thank you. Next question. Please, could you show us which tool to use for the lights? So I suppose you mean how to create all the different lights, right? Maria, maybe you can define your question a little bit more.
So maybe I can start already with an explanation, because what we have shown in here is actually we have shown the impact of the light. So it's not a full lighting simulation. It's really a plausible impact of the light, how it is really impacting the appearance of the material and the surfaces. So, and that's done with a CATIA live rendering, which is embedded in the Visual Experience Designer. And this can give you already a very, very good capability to analyze the perceived quality, and also give you all of the, can answer very integrated all of the questions you might have during the design process. If you really want to see inside the light and want to work on the inside of a lamp, for instance, then we work together with a new partner, Synopsys, on a solution to make also these lamps visible. But what we're showing here was really the impact of the light from the product itself on the perceived quality of a surface and a material, and we used CATIA live rendering here.
Very good, thank you. We have one question from the community as well about tolerances. Can the simulations of tolerances be saved and reproduced, or do we always have to recalculate?
I think I can talk over this question. It's a very good question, actually, because obviously if you do something like this, you want to do this persistent and want to redo the analysis again. And that's a good thing on our 3D Experience platform, because all the data are managed. So basically, it's a physical product. Then you enrich the data on 3DCS, and then as soon as you save it, it's saved in the scenario container, and the data is all the time available for you.
Very good. We have another question. It's a bit complicated, but let's try. As a program for one car design, the gap and flush is decided, as seen in your presentation. There was changing gap and flush. Is this with the stack-up tolerance?
Yes, that is correct.
That was short.
Simple answer like that. Yes.
Very good. Okay, let me just quickly check if we have more questions in the communities. There are quite a few chats that I have to take care of here. But I think we're almost done. Sorry, my laptop is quite slow and it loads awfully long. Okay, I think that's it. For all of you who were asking questions about how to get CATIA on the platform and how to get certifications for CATIA, please go to 3ds.com and check it out. You will get all information there. You can book trainings and get certifications for all kinds of CATIA programs. So it's up to mechanical, engineering, design, whatever you need. And no, it's not free. So you can, when you're a student, you can get in a certain time of the year, we give out free student licenses, which should come again just before the start of the new semester. I think probably September, October. And yeah, I think that's it from me. If there are no more questions, I would say visit us in the 3ds CATIA Creative Design and Styling community, like you see below, the link here. You can discuss with the experts, you can ask questions, you can share your products with us, and that would be just great. I see we have one last question. Let me put it up here and then it should be it. So are you looking for a lower drag coefficient in the final design? Can you come up with something? Can you answer this question? Does it make sense for you, or if not, I would.
Maybe we should iterate over it in the community, because
Yeah.
Maybe you
I
can
don't
come
understand
back
what
to the
exactly the
community and
question should
ask the
be.
question there, and then we can discuss it there. Okay, so that was great. Thanks for following us. It's now time to go into our well-deserved summer break. I wish you a wonderful summer, nice time, and take care, recharge. And I see you back on September 27 with our CATIA design champion, Tony Pares Edo Martin, and he will introduce his new concept design of an air purifier. Have a great time. Thanks for following us. Bye-bye.
Thanks a lot. Bye-bye, everyone.
Thanks. Bye-bye.